obtain dy du by differentiating y with respect to u, as you can observe. Then we also obtain du dx by differentiating u with respect to x. So that is what we're going to do. So meaning from u equals 2x plus x, du dx would be du dx would be, if we differentiate 2x, we get 2. The x disappears, plus if we differentiate 6, which is a constant, we get a 0. So meaning our du dx would be equal to 2. And then from y equals to u cubed, our dy du would be obtained by differentiating y with respect to u. So meaning we would have dy du being equal to, if we differentiate u cubed, we get 3u squared. That is 3 times u power 3 minus 1, originating from the rules we looked at. Meaning our dy du will be equivalent to 3u squared. 3u squared. That is, in case we reduce the power of 3 by 1, we get 3u squared. So meaning we have, from the rule, we have dy du as 3u squared, and then we also have du dx as 2. So we can then now find our dy dx by substituting those variables into a template. So our dy dx would be which would be equivalent to 3u squared times du dx, which is 2. So meaning our derivative would be 6u squared. 6u squared. So because we need the derivative in terms of x, so we can then bring back what we let u to be. Remember, we let u to be 2x plus 6. This expression, which was in brackets, we let it to be our u. So meaning at the final stage we bring back what our u was in terms of x. So meaning we would have our derivative as 6. So where there is u, we put what u was initially, and this would be our derivative 6 into 2x plus 6 squared. That would be the derivative of that expression. So that is how we would find the derivative of y into 2x plus 6 power 3, as you can observe. So that is the last rule of the rules we need to understand when it comes to differentiation. Now we can continue other segments. So now we have small changes in economic variables. We have small changes in economic variables. Small changes in economic variables. So the first one is the marginal cost MC. So you find that marginal cost is that extra cost incurred to produce an extra unit of output. So how do we obtain the marginal cost? The marginal cost is obtained by differentiating the total cost function. So you obtain the marginal cost by differentiating the total cost function. Then we have average cost. So average cost refers to the cost per unit of output. Average cost refers to the cost per unit of output. So we obtain the average cost by dividing the total cost by the units of output. That is how we obtain the average cost. Then we have marginal revenue. So marginal revenue refers to that extra revenue earned when an extra unit of output has been produced. The result is what we call the marginal revenue. So how do we obtain marginal revenue? So marginal revenue is obtained by differentiating the total revenue function. So meaning marginal revenue MR is equal to the R dq, where R represents the total revenue and Q represents the units of output produced. So that is how we obtain the marginal revenue, as we've seen the principles of differentiation. So we are able to differentiate any function given to us, and the result when it comes to total revenue, when you differentiate a revenue function, the derivative is what we call the marginal revenue. The same applies to cost. If we differentiate a total cost function, we get a marginal cost function, as we're going to observe as we proceed. Then we can continue. We have what we call the average revenue. So the same, the average revenue is obtained by dividing the total revenue by the units of output or the units produced. So this is how we find the average revenue. So where R is the revenue function and Q being the quantity of output, average revenue is also represented by a symbol P, since it's the price per unit. So in other words, the average revenue function is the same as the price function and is the same as the demand function. You can take a note on that. Note. So average revenue function is the same as the price function. It is also the same as the demand function. So whenever you're faced with a question giving any of those, so you must know that the price function is equivalent or is the same as the demand function or is the same as the average revenue function. They all mean the same thing. So once you meet it in a question, don't get confused by that. Then you have a point of maximum profit. Point of maximum profit. So a point of maximum profit, normally you find that this is the point where the marginal revenue is equivalent to the marginal cost. So this is a point where the firm's marginal cost, MC, is equal to its marginal revenue, MR. So at this point, the gradient for both the cost and revenue functions intersect each other. So you find that at a point of profit maximization, at this point, at the point of profit maximization, marginal cost is equated to marginal revenue. So we find that when you equate marginal cost to marginal revenue and work out to obtain the quantity, that quantity would be the profit maximizing quantity. That is the quantity at which marginal cost is equal to marginal revenue, as we shall see when we are moving on. So you have the break-even point. Break-even point. This is a point where the firm neither makes a profit nor makes a loss. In other words, the firm is just able to recover its costs. It is just able to recover the cost of investment. So you find that it makes no